All right, welcome back to Module 3. I'm your professor, Professor Fiske, and today we're going to talk about recursion in programming in C. Now, this is an advanced concept, and I don't expect you guys to catch on to this just yet, but it is something that I think is worth discussing. What is recursion? Well, recursion is the action or the act of making one call oneself. In this case, a recursive function or a recursive loop is a recursion type action where the function calls itself. Now, I know that sounds crazy, but there are certain situations where that's what you want, right? So, for instance, let's say you had a function that was asking the end user for input, and the end user did not give you the input that you wanted. You can write a while loop, sure, you can do that, or you can write a recursive function, and it would look something like this. Now, I'm not going to write it correctly because strings are weird in this case. Actually, we can get away with this. So let's do a thought experiment. Let's say we want a function that returns a value between 1 and 10. So determine value of int. Great. And we're going to say int input as our parameter because we need the input to go in. And now what I'm going to do is I'm going to get rid of that and get rid of this in our main. And in my function, what I want to do is I want to get an input from the user. So int input, I like using the same variable names because of the scope, so I'm going to do this from now on. Don't get too miffed by it. If int input, okay, and the input should equal 0 because we always assign values to a variable when we initialize it, and then scanf and printf. So we're going to print, right, f, and we're going to say, please enter a number between 1 and 10. Great. We don't really need f because there's nothing to pass to it, so hopefully that doesn't get too upset about that. Is it the that you're angry about? Wow, okay. Scanf, now we want to get that value and put the value into the input, so we're going to say the answer is this, and that's what it should be. Percent sign D, and I think we did this in the first module or the second module or something like that, but either way, percent sign D, and then we're going to ask for the input, so we'll say assign this to input, and off we go. We've seen this before. Now what we want to do is we want to take that input and we want to send it somewhere, okay? So we want to print f, and in my printf function, I'm going to say, I want to say, what do I want to say? This is recursion, right? All right. I want to say the number is, and then return value of int, and I want to pass that the variable input that's sitting here. Great. So now let's go to the function. What do I want to write in the function? Well, I want to write the code that I want to fire. So in this case, I'm going to say if input. I don't remember how I did this. How did we determine if the input was not a number? There was a way to do this. Writing in too many languages. Is digit? Oh, okay. So is digit is the value? Is a variable? Or the function, sorry? Doesn't sound right at all. Interesting. Is digit. Is not digit. What I want is not is what that means. So that's bang or exclamation point. From now on, you will call it bang sign. If that is not a digit, and I guess I need a implicitly declaring library function is digit with type int. Yeah. So what's the library? Give me the library. I mean, I don't really need it. So if it's not a digit, well, then you need to print, hey, bud, this is not a digit, a number. Please try again. And to ensure that they try again, we're going to say determine, actually, all of this stuff needs to be in the function as well. Yep. Then we're going to say determine value of int input. Awesome. We don't need this. Great. We also don't need the input anymore because now we're having the function call. We're having the function ask for the input. So we need the int input back. And there we go. This is still implicitly calling the library, but I don't know what the name of the library is. So I wonder if that's the library. No? Is that the library? Nope. That's the library. Perfect. Great. So what it was saying is that I wasn't calling the library explicitly, meaning it wasn't in the code files, and I should probably do that so I don't run into issues with two lines of code that say the same thing overriding one another. Okay, so I don't want to write the rest of this. What I want to do is I want to show you how this recursion works. So I wrote a function that's doing a lot of work. Okay, it's doing a lot of things by itself. This is not normally how we would do this, but this makes sense in a vacuum. So we're going to run this. We're going to start at the main. This is where everything starts, at the main. Okay, it did ask for, and I don't know if it's because I didn't click the debugger one. Okay, boom. We're in the debug session. All right, what's going to happen? Well, the innermost parentheses are going to fire first because of PIMDAS, because of order of operations. Please excuse my dear Aunt Sally. Parentheses is going to fire first, and the innermost parentheses is going to fire first. Because there's nothing in the innermost parentheses, then the function name is going to get called and executed, and that will fire next. So now we should jump into the function, and there you go. We jumped right into the function name. The name of the function, the way I wrote this function, is camel case, which is the first word has a lowercase name, and the second, and every subsequent word after that has uppercase first letters. Very important. This nomenclature is not negotiable in most development communities and most development environments, especially teams. Okay, first line of code in the function is int input equals 0. We're declaring and initializing or assigning a value at the same time. So we're going to initialize, that's what this is called, initializing the variable int. Now we're going to ask the end user, me, to do something. Okay? Now we're going to ask the now we're going to wait for the end user input. So here we go. Please enter the number between 1 and 10. We are not going to do that. We are going to purposefully trigger the unhappy path that we wrote here. All right? So let's do that. We're going to go EE. Then we're going to press enter. And now we're stepping into the decisions. The decision is, if isDigit is not equal to, or if this input value that I gave to it is not equal to a digit, then this should be true, and the if statement should fire its programming block. It is true. It's not equal to a digit, and therefore we need to print to the user, this is not a number, please try again. And then I want to run this program again. Now the problem here is this isn't going to work right because I had the input there, but let's see if it does. It went right back to the top of the function like it was a loop. And it will continue to do that every single time. Here we go. And so if I ran this without the debugger, so run, and I put EE in here, recursion. Now, that recursion is not stopping. And at some point in time, I want it to stop. And I'm not going to develop that right now. But in C, you kind of want this scanf to get hit again. And it looks like it wasn't hit again, which is bad. But either way, we'll figure that one out another day. In the end, this is what recursion looks like. Most of the time, in lower level languages like C, recursion is not necessarily the greatest because it doesn't give you the same portability that an actual loop does. So shy away from recursion whenever you can and use actual loops. So as I say in all of my videos, I absolutely love your feedback. Please like and subscribe if this was your cup of tea to let me know if you are enjoying this content. And I will see you in the next video. Good luck. Have fun. Ciao.